Hey everybody, I wanted to go through and document what we've done to my son's Dune Racer up to this point. The idea was to take this that was gifted to him, working perfectly fine, minus the dead battery and no charger, which we'll sort out in the next phase, but add a little more control, give him a more realistic pedal and potentially a bigger battery with a little more voltage down the line. But before doing that, I just wanted to add a little more realistic control for him in the form of either soft stop system or, in what we have this case, a variable speed pedal. And what we ended up with is actually both. So I wanted to run through that and document what we have up until this point, because it looks like it's going to work out as planned, or document the complete failure that might turn out once we button everything up. But what we have, just a temporary bench setup to the battery, which again we're going to sort out later. I'd like to use a big battery like this if it fits in the battery compartment, but that might take some modification, so we might do something different there. But otherwise, this is the PWM that we sorted out, and the difference that I found in this one is that there's a pedal interface directly to the PWM. So if we can zoom in, you see there's two connectors there. What we have connected to is the variable speed pedal option, and this particular company, I'll put a link in the description below, we had a soft stop pedal. So I guess it's just more of a binary on-off, similar to what the original pedal was. But in this case, it turns out that the variable speed pedal does both. So really quickly, I'll show you what this pedal does. If they were to engage slow or incremental press of the pedal, you get a slow speed. I'm going backwards at the moment. I'll go forward just to show you that works. You get back off, go back to full speed. So at the moment, this is still 12 volts. So speed should be comparable to what stock was. But what's nice about this pedal, as I mentioned, this is the best of both worlds for soft stop and variable speed. If the driver happens to just jump on the pedal, you'll notice that the soft stop feature is still enabled. So I think it's about a 3-second soft start, soft stop in both cases. So if you were to stomp on the pedal, a little bit of a delay to get started, but otherwise the soft start kicks in. So down the line, if we decide to upgrade the batteries, go for a higher voltage, we'll start saving some gearboxes and potentially get some bigger motors for that as well to up the speed. But in following with the system, so the pedal again interfaces directly with the PWM. This does have the potentiometer, so if there's a new operator or a younger operator that you don't want to have the full voltage, whether it's 12 volts or more, you can still control that. Just make sure it's turned up high enough so you get something. Yeah, one of the wires was a little bit loose, so once we get everything buttoned up, it'll be a little more secure connection than alligator clips. So the potentiometer can be lowered so that you do get a slower speed if you have a younger operator. So again, pedal directly to the PWM. What I was trying to do, and I think we were for the most part successful, is that I don't want to cut too many wires on the original system, so you could go back to stock if you really wanted to. So this was the connector to the original pedal box, which we did use with the exception of mounting the new variable speed pedal to it. So the original 3-pin connector came out here, that interfaced with this system here, which, if you come back to this jumble of wires, has two double pole, double throw switches, which all stayed intact. Nothing was cut here, nothing was modified with the exception of pulling out the first gear, second gear switch out to take that out of the equation. The stock setup uses the shifter to go from first speed to second speed, so which right now it's limp because that second switch is not there. Reverse is still operational. And that was important. I wanted to at least keep that realistic feel so that my son could play with the shifter, and feels a little bit more fun to do that rather than just a rocker switch sitting somewhere in the cabin. So that is operational. This switch is still functional. It's in high speed and will remain outside the shifter box, so that it's always putting out 12 volts. The way it's wired, to my understanding, the shifter switch will simply reverse polarity so that you can operate forward speed or reverse, and the other double pole switch will cut it down to, I think, 6 or 9 volts, I guess in half from the 12 volt battery. So when you take that out of the gearbox, you're essentially keeping it at high speed. So the thing to keep in mind too is, if they were to put it in reverse, you could go full speed if we turn the potentiometer all the way up. It could go as fast backwards as it does forward. So something that the operator will have to be aware of, or the supervisor will have to keep an eye on, so that they don't back up into a tree or something a little bit more dangerous. So we're keeping that out of the equation, and then they still get to play with the shifter. And then from here on out, everything is the same. Wires go to the 2 motors. I did eliminate the connector for the battery because we're still sorting out whether we're going to keep that battery location or might move to the frunk, depending on the biggest battery I can cram in there, or whatever battery is available. Maybe go with a drill battery, etc., if we go higher voltage. But otherwise, pretty stock. So next phase, we'll button everything up, maybe run a new lead if we're going to put a battery in the front. But we'll put everything in, get rid of the alligator clips, and put the shifter back in there like so. So far it's working as expected. I'm happy that we have a variable speed pedal. Next is to button everything up. And then the last piece, just to show you, once we get a more permanent solution for the battery, the dead Fisher-Price battery, remove the connector as well as the other side of the connectors from the car. We'll reuse those in a more permanent fashion. And of course, adding a fuse connector. In this case, this was, I believe, a 5-pack with 30 amp fuses, 12 gauge wire. So we'll be incorporating that to the battery in its final form. But yeah, next phase, we'll button everything up, start sorting out where to put the battery, and get it back together for the kid. What we ended up doing is putting the battery in the front compartment. We had an old battery that was still working. It's only 7 amp hour, but just to get rolling, we're going to use that. Also ran some leads to the back compartment in the plan of either adding 2 batteries in parallel, maybe in series, but we still have the extra leads back here to do that if we desire at that point. The original leads integrate with the wiring, which get a little more complicated, so we may or may not use those, but just in case, direct wiring from the front compartment to the back compartment to tie into the battery or the speed controller. So as an update, what we have here is the small battery that we decided to use fits near perfectly in the front compartment. That was the reason why we decided to go with that. So not the connector I was planning to use, but for the moment, these spade connectors slip in there and they're pretty secure. So from the battery to a fuse, well, actually, I'm sorry. So battery, we integrated a switch, which we'll get to that in a moment. So just a disconnect so we can turn off the speed controller so there's no extra drain while not in use. And also just for safety and an extra switch for the kids to play with.
How do you like this?
That's great. So from the switch back to the speed controller, and then connected to the speed controller is this voltmeter. Also has an amp gauge on it, which we're not using at the moment. So there is another version of this speed controller, which I mentioned, we'll put a link in the description below, that has an integrated low voltage cutoff. That was a consideration. I decided against it simply because if the battery gets too low, I didn't really want to push this back home or up a hill. So instead, we'll just keep an eye on the voltage from here, and guess my son will learn what a low battery voltage looks like and how to get it home before that happens. So again, the switch is prior to the voltage meter, and then from there we come into the pedal box and the original wiring. Like we mentioned, the variable speed pedal is still integrated, so when the switch is on, the potentiometer on the speed controller is turned all the way up. We're in forward, only two positions at the moment. We eliminated low speed, so forward, variable speed pedal, and then the more you press, faster she goes. And then same for reverse. Okay, so that's everything. We ran the extra leads just in case we add some batteries in the back, but otherwise I think everything's wired up and in place. So we'll put the plastics back on. All right, we're all back together and we're about to take our first ride. So I think we got everything back in. Got a thumbs up from our driver. First thing we're gonna do, we hit our main switch. Full battery, 13.2 volts. All right, let's give it some throttle. Nice and slow to start. Go ahead. And he's out. All right, we got ourselves a little bit of a hill. Let's see how that soft start helps us. All right, we were going through and the 12-volt battery, 12-volt, 7-amp-hour battery fits, works as it should. The only thing we noticed was it doesn't feel like 12 volts. When it was directly connected before the speed controller was ever involved, it just feels like we're getting less voltage to the motors. So we went straight for it. Now we're going to put an 18-volt DeWalt battery in and see if that picks up the slack. So, Mr. Driver, go ahead and hit the switch. See how many volts we're getting. There we go, 19.9. Pop it in reverse.
It popped.
Pops. Okay, go ahead. Nice and slow. Oh. Seems like it has a little more pep. It's a little more like it. All right, I call that a success. So now we're running 18-volt battery. I think probably stick with that for the time being. Seems to be about comparable, maybe a touch faster than the 12-volt stock battery. And then from here, we might go 24 volts or beyond. But at least we have a speed controller. We could always limit that if we want to. The driver will get better with his variable speed pedal, soft stop, soft start, so that we're not tearing up any gearboxes. But I think this was a success.